in this video series I'm trying to make the videos on numerical problem. So I'll begin with the pressure, one of the very important chapter, and from the pressure I will start with something that's based on the law of flotation. And students are often confused with this topic, but it's quite easy. But before doing the numerical, let's try to understand the theory, the concept behind this. Now law of flotation states that, okay, and the mathematical I can write over here, the weight of body must be equal to weight of displaced water. That is, if a body has to float, it has to displace water, it is equal to its own weight. Now if a body has a weight of 500 Newton, now this body must displace water equal to 500 Newton. So we have weight of body is equals to weight of water displaced. Now the weight formula of weight is, that is, m into z. So similarly, weight of water displaced, same formula, we have m into z. This is the body, so I'm writing here b, and this is water, so I'm writing here water. Now g and z, they will cancel out, or we can, from here we can see a conclusion that mass of floating body must be equals to mass of displaced water. Or we can also write over here, now mass in terms of density and volume, so that will be d into v will be equals to d into v. Now we know, since we know the formula, density is equals to mass by volume, so mass will be density into volume. So this is a body b, so this is water w, this is water w. So we have here a certain relation, so density of body, volume of, this is the body, similarly density of water and volume of displaced water, and this relation will be quite useful when we are dealing the problem. So okay, so in general in exam we are asked part of object inside water. An object is kept in water, it's floating, and you are generally asked what part of object is inside water, and there you have a formula. So the formula is volume of, volume of displaced water, volume of displaced water divided by volume of object. Okay, now first we have to try to make the sense of the formula. If you try to have a sense, if you try to understand the formula, this will give you ease. Okay, so let me try to give you an example so I can make you understand the formula. So consider we have a choco pie, and I divide the choco pie into 4 parts. Okay, now consider we have eaten this much part. This is the part of choco pie that we have eaten. So what part of choco pie have we eaten? Part of choco pie that, okay, that I have eaten, okay, will be equals to, okay, now part means always in compare is in ratio, so total part there are 4, okay, total part, because you can see 1 2 3 4, so there is a total part, that is 4, so this is the total part, or you can say it's the total volume, it's the total part. Okay, you can say total part as a volume, so you have the total part, and how much part I have eaten. Okay, so that is the portion I have eaten. Okay, I'll say that portion I have eaten. So you can see that easily whenever I say the part of choco pie I have eaten. Now this expressed in terms of ratio. Okay, the same concept is over there, part of object inside water. Now consider an object, there is an object over here. Okay, this is an object. Okay, now A B C D is an object. Now it's kept in water and it is floating. Now whenever something is floating, certain part is outside and certain part is inside. Now this much part is inside water. Okay, this much part is inside water. Now what part is inside? That means this part, okay, this part divided by, okay, now let's give the name A B C D, and I'll write here E and F. So this part, so part of object, you can say over here, part of object, okay, part of object inside water So this will be equals to, so what part is inside? So part inside. Okay, so that is the here we have part portion, no, part of choco pie I have eaten, that is the portion we have eaten, that this portion we have eaten. Similarly, in this case, the part that is inside the water, so the part that is inside water is this portion, that is E, C, D, F. Now this is the part, okay, that is inside the water. Now we can simply say this is the volume of object, volume of object inside, volume of object inside water, divided by what you can say, volume of object. I hope from up to this it's make a sense. Okay, now the problem is there in the formula, we don't have volume of object inside water, there is volume of displaced water. Now our second part, okay, we have to remove this and we have to show that what we have to show. Now we have to show that volume of displaced water, okay, volume of displaced water. Now this must be equal to volume of object inside, okay, inside water. So let's try to do this. So to understand this concept, we have to start from the Archimedes. So you have read something about Archimedes, okay, in class 8. Okay, in class 8 we have a concept, we have to find the volume of irregular object. Okay, now there, to find the volume of irregular object, like a stone, what you do, you take a stone. Okay, first we take a measuring cylinder, we have certain kind of measuring cylinder, and first we note the volume. This is a V1 volume. You keep the stone, as you insert the stone, you will notice that the water level will increase. Now why the water level has increased? Okay, that's a thing. Okay, now say now water, they occupy space. Now when we say space, that is the volume, it occupies certain volume, certain space. Now when you keep the stone, now water is movable, the water flows, it moves, they are not so rigid. So when you keep the stone will displace the water, that, okay, it will displace the water, all of the water over here. That means that is going to be the volume of the stone. So displaced water will move up, so this much water is displaced. So what is the idea over here? So the idea is volume of a stone must be equal to volume of water displaced, Okay, so here, if you saw that, if we have seen that the object is completely inside the water. Now what if the object is not completely inside water, it is somewhat like a floating? Okay, now consider the next case. If the object is, if we keep the stone like this, okay, now this is not completely inside water, in this case too the water will come up, the water will be displaced. Now in this case, the volume of displaced water, what it must be equal to? So the volume of displaced water will not be equal to volume of stone, definitely. So this will be equal to this much volume. That means the volume of object inside water. So we have here concept. So here volume of water displaced. Okay, volume of water displaced. Now this must be equal to, okay, this must be equal to volume of object, okay, volume of object inside water. And this makes a sense, it gives generalized. Now if the object is completely water, okay, if object is completely, if the object is completely immersed, okay, that if object is completely immersed, now in that case automatically volume of object inside water, this will be equal to volume of object itself, so which is the case we have discussed before. So here we have very important concept. Now the important concept is that volume of water displaced must be equal to volume of object inside water. So we have the previous formula. Part of object inside water is equal to volume of object inside water, volume of object inside water divided by volume of object. Now we have seen that from the Archimedes concept that volume of object inside water is equals to volume of displaced water. So the above formula can be written as part of object inside water is equal to, so that will be volume of water displaced divided by volume of object. So now we'll see some some examples that will help us to clarify the concept. Okay, and this question are quite important for exam, so I hope this video will help you.